We'll continue with the final exam review. The final is on Monday, May 3rd from 3 p.m. to 5 p.m. We were working on this one last time. Simplify the square root of 20x to the second y divided by the square root of xy squared. So I wrote it as a single square root of a rational expression. And then I partially simplified that rational expression. But since we already have y to the second in the denominator, I am going to avoid canceling one factor of y. If we did, we would have to put it back in when we rationalize the denominator. So this just saves a little bit of work. And then we can rewrite this as the square root of 4 times 5 times xy in the numerator, because 4 times 5 is 20. And the largest factor of 20 that's a perfect square is 4. And then the denominator is the square root of y to the second. And then the last step, simplify the numerator. The square root of 4 is 2. So in the numerator, we get 2 times the square root of 5xy. And in the denominator, the square root of y to the second is y. In the next problem, we have a system of 2 linear equations. And we want to solve this. And the answer will be an ordered pair if there's one solution. So this looks like it might be nice to use the addition method. If we multiply both sides of the top equation by 3, we'll get 9x minus 6y equals 57. And leave the bottom equation the same. 5x plus 6y equals negative 15. And when we add these two equations together, the variable y will be eliminated. And so on the left-hand side, 9x plus 5x is 14x. On the right-hand side, 57 plus negative 15 is positive 42. Then divide both sides by 14, we get x equals 3. Then to find y, we can use any one of the equations. I'll just use this one. And in this equation, replace x with 3, and then solve the resulting equation for y. So 5 times 3 plus 6y equals negative 15. 5 times 3 is 15. We'll subtract 15 from both sides, and we'll get 6y equals negative 30. And then divide both sides by 6. We get y equals negative 5. So the solution as an ordered pair is the ordered pair x, negative 5. Oops, what am I doing? X is 3. The y coordinate is negative 5. So that is the ordered pair solution. The next problem, number 27, is a work problem. This one says Blanche in Lavina can rake a yard in 28 minutes. Working alone, Blanche takes 4 minutes longer to rake the yard than Lavina would working alone. So how long would it take Lavina to rake the yard alone? And then round to the nearest minute. Well, we're supposed to find how long it takes Lavina by herself. So if I pick T to represent the number of minutes it takes Lavina to rake the yard alone, then Blanche, we are told that Blanche takes 4 minutes longer than Lavina. So for Blanche, T plus 4 minutes is how long it takes her. And so we can write down 3 equations, each having the form rate times time equals 1. For Lavina works at a certain rate for T minutes to rake 1 yard. Blanche works for T plus 4 minutes to rake 1 yard. And then when they work together, they can rake the yard in 28 minutes. So Lavina's rate plus Blanche's rate times 28 equals 1. So we solve each of those 3 equations for the rates. Lavina's rate is 1 over T. Blanche's rate is 1 over T plus 4. And the sum of the rates, Lavina's rate plus Blanche's rate, is 1 over 28. Okay, in the next step, we will finally get our equation whose only variable is T. So Lavina's rate is 1 over T plus Blanche's rate 1 over T plus 4. And they add up to 1 over 28. The least common denominator is 28 times T times the binomial T plus 4. And when we multiply every term on both sides of this equation by the least common denominator, multiply that by 1 over T, the T's cancel, so we're left with 28 times T plus 4. Multiply the next term, 1 over T plus 4, by the least common denominator, the T plus 4 factors cancel, so we're left with plus 28T. And on the right-hand side, 1 over 28 times the least common denominator. The 28's cancel, and we're left with T times T plus 4. This is a quadratic equation. So I ran out of room, but on the left-hand side, 28 times T plus 4 is 28T plus 112 plus 28T. On the right-hand side, T to the second plus 4T. So I'll put another piece of paper here. We'll take it a little further. On the left-hand side, we have a total of 56T. So we'll make the left-hand side 0 by subtracting 56T from both sides and also subtracting 112. So we'll get 0 equals T to the second minus 52T minus 112. Then we can use the quadratic formula with A equals 1, B equals negative 52, and C equals negative 112. And we get T equals the negative of negative 52 plus and minus the square root of the number negative 52 squared minus 4 times 1 times negative 112, all divided by 2. So notice that since inside the square root we're subtracting a negative, that's the same as adding a positive. The square root of this number is going to be bigger than 52. So the solution that we want is the one that we get by adding. So I'll just write t equals 52. The negative of negative 52 is 52. And then plus the square root of that number, all divided by 2. So let's see, when we square negative 52, we get 2604. That's what I got. And then we're subtracting negative 448. So that's the same as adding 448. And I'll just do one more step, and then you can do the rest with a calculator. So inside the square root, 2604 plus 448 is 3052. But you might want to check my arithmetic. Okay, let's move on then to the next page. Well, the next problem. That's on the same page. Solve the equation 4 times the square root of x equals x plus 4. We want to solve for x. We see that the square root of x is in the equation. So we want to square both sides of this equation. So square the left-hand side, square the term 4 times the square root of x, square the right-hand side. And remember that when you square something, you multiply it by itself. So 4 times the square root of x times 4 times the square root of x on the left-hand side. On the right-hand side, x plus 4 times x plus 4. So if you write it out this way, it might remind you and help you avoid a mistake. So 4 times 4 is 16, and the square root of x times the square root of x is x. And then on the right-hand side, when we multiply x plus 4 times x plus 4, we get x squared plus 4x. And then we get plus 4x again, and then plus 16. Well, we get another quadratic equation. So if we simplify the right-hand side, the equation becomes 16x equals x squared plus 8x plus 16. And then subtract 16x from both sides, we get 0 equals x squared minus 8x plus 16. We can solve this by factoring. If you would rather use the quadratic formula, you can. But this factors really nicely. The two factors are x minus 4 and x minus 4. So this equation has exactly one solution. It's a repeated solution, but there's just one solution. And then we should, since the original equation involves the square root, we should check, replace every x with 4. So 4 times the square root of 4. We want to know if that's equal to 4 plus 4. And sure enough, 4 times the square root of 4 is 4 times 2. And the right-hand side, 4 plus 4 is 8. So that's true. That means x equals 4 is the solution. All right, on the next page, This says graph the parabola y equals negative 2x squared plus 12x minus 16. Find the x and y intercepts and the vertex. Well, over here I'll write the y-intercept, since that's the easiest thing to find. Replace x with 0. And when x is 0, the y-coordinate is negative 16. Let's go through the completing the square process to get this into vertex form. So that involves factoring negative 2 out of the first two terms. We don't factor it out of the constant. So we just factor negative 2 out of the x squared term and the x term, but we leave the minus 16 on the outside. Then on the inside of the parentheses, we want to add 0, but we pick adding 0 in such a way that we get a perfect square trinomial. So if we focus on x squared minus 6x, to get a perfect square trinomial, we have to add 9 to it. 1/2 of negative 6 is negative 3. When you square negative 3, you get positive 9. So plus 9 minus 9. Then in the next step, we keep the perfect square trinomial, x squared minus 6x plus 9. And then if we look back at the previous step, we multiply negative 2 times negative 9, which is positive 18. So on the outside of the parentheses, we write plus 18 together with the minus 16 that's already on the outside. And then in the next step, we can write the vertex form. Y equals negative 2 times the binomial x minus 3 squared plus 2. So now we can just tell what the vertex is by looking. The x coordinate of the vertex is positive 3, and the y coordinate is positive 2. To find the x-intercepts, replace y with 0 and solve for x. So 0 equals negative 2x squared plus 12x minus 16. And now that we're just solving an ordinary quadratic equation, we can divide both sides by negative 2. That will make the arithmetic simpler. 0 divided by negative 2 is 0. Divide each term on the right-hand side by negative 2. We get x squared minus 6x plus 8. And this factors really nicely. The two factors are x minus 2 and x minus 4. So the x-intercepts are 2, 0 and 4, 0. So in our limited space here, we can get a rough sketch. We can at least get the x-intercepts and the vertex. And the y-intercept will be off the grid in this case. And the vertex is the ordered pair 3, 2. We should know that the parabola opens downward. So this is the high point, 3, 2. One of the x-intercepts is 2, 0. The other one is 4, 0. Oops, 2, 0, 4, 0. And then you can draw the parabola that opens downward. Okay, number 30, solve the inequality. 1/2 minus 4 over x squared is less than or equal to 1 over x. So this is a rational inequality. We have to do some work to get it in the form that we want. So we want one side to be 0. So we will subtract 1 over x from both sides. And then we want to write the left-hand side as a single rational expression with a common denominator. So the least common denominator is 2x squared. So if we multiply 1/2 by 1 in the form x squared over x squared, we'll have the common denominator 2x squared. And then multiply the next term by 1 in the form 2 over 2. Then we'll have the common denominator 2x squared. And then multiply 1 over x by 1 in the form 2x over 2x. And we'll have the common denominator 2x squared. So in the next step, we can just write the common denominator 2x squared. And then be careful with the arithmetic for the numerator. So in the numerator, we have 1 times x squared, and then minus 2 times 4, which will be minus 8. And we'll also have a minus 2x times 1. So I'm going to put it in standard form. X squared minus 2x minus 8 is less than or equal to 0. Okay, now we want to find the endpoints. So I might have to use more paper in a minute, but the numerator factors really nicely, x squared minus 2x minus 8. The two factors are x plus 2 and x minus 4. And the denominator is just 2x squared. So the endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. So the endpoints are x equals -2 from the numerator. The other factor, x minus 4, means that x equals 4 is a endpoint. And when x is 0, the denominator is 0. So x equals 0 is an endpoint. So on the number line, -2 is to the left of 0, which is to the left of 4. So we have 4 intervals to test. I'll use extra paper here. So in this first interval on the left, let's pick x to be -3. And we can use the factored form of the inequality. Replace every x with -3. So in the numerator, -3 plus 2 is -1. In the denominator, also in the numerator, -3 minus 4 is -7. But in the denominator, we have 2 times the number -3 squared. This is just going to be a positive number. The numerator is +7. The denominator is +18. And the inequality is less than or equal to 0, which is false. So none of the numbers in that first interval or the left interval are solutions. In the second interval, pick a number between -2 and 0, so I'll pick -1. And then in the factored form of the inequality, in this factor x plus 2, -1 plus 2 is +1. And -1 minus 4 is -5. In the denominator, 2 times the number -1 squared is just +2. So this number is -5/2. The inequality is less than or equal to 0, and that's true. So the numbers between -2 and 0 are solutions. Then in the third interval, pick a number between 0 and 4. I'll pick x to be +1. And in the inequality in factored form, 1 plus 2 is 3. 1 minus 4 is -3. In the denominator, 2 times 1 squared is just 2. So we get -9/2 is less than or equal to 0. That's true again. So the numbers between 0 and 4 are solutions. And then in the fourth interval, pick a number greater than 4. So I'll pick 5. And then in the factored form of the inequality, 5 plus 2 is 7. 5 minus 4 is 1. In the denominator, 2 times 5 squared is 50. +7/50 less than or equal to 0 is false. So none of the numbers in the fourth interval are solutions. Okay, what about the endpoints? Well, the inequality is less than or equal. So the endpoints that come from the numerator are included. So those endpoints from the numerator are -2 and +4. But any endpoint that comes from a denominator is never, ever included. It doesn't matter what the inequality is. Division by 0 is undefined, so we always exclude endpoints that come from denominators. So we have sort of a unique case. All of the numbers between -2 and 4 are solutions except 0. And the endpoints -2 and 4 are solutions. So the interval notation, well, this interval on the left, bracket -2, 0, parenthesis, and then we use the union symbol. parenthesis 0, comma 4 bracket. The only number excluded between -2 and 4 is 0, so we need to have a union to show that 0 is excluded. So that's the interval notation. All right, the next problem, solve the equation x squared minus 6x plus 25 equals 0. We can always use the quadratic formula. Solving by completing the square always works. But let's just use the quadratic formula. A is 1, B is -6, and C is 25. So we get x equals the negative of -6 plus and minus the square root of -6 squared minus 4 times 1 times 25, all divided by 2 times 1. Then in the next step, x is equal to +6 plus and minus the square root of 36 minus 100 divided by 2. 36 minus 100 is -64, so x equals 6 plus and minus the square root of -64, all divided by 2. The square root of -64 is 8i, 8 times I, because the square root of -1 is replaced with I. So x equals 6 plus and minus 8i divided by 2. 2 is a common factor of both terms in the numerator and the denominator. So if we divide every term in the numerator by 2, we get x equals 3 plus and minus 4i. So if you write the solution separately, one is x equals 3 minus 4i, and the other solution is x equals 3 plus 4i. The next problem, this is a uniform motion problem. So think of equations of the form rate times time equals distance. So this one says in 1.5 hours, Staley rode a bike 12 miles and then ran 4 miles. His biking rate was 4 miles per hour faster than his running rate. Find his biking rate and running rate. Okay, so I'll pick a variable for the running rate. I'll pick x, it measured in miles per hour. And then the biking rate. The biking rate was just 4 miles per hour faster than the running rate. So we represent the biking rate with x plus 4 miles per hour. We're told what the total amount of time was for biking and running, but we don't know precisely what the individual times were. So we'll write down an equation of the form rate times time equals distance for running, and then another rate times time equals distance equation for biking. And then we'll use the fact that the total amount of time biking plus the total amount of time riding, or running, I should say, is 1.5 hours. Okay, so when running, the rate is X miles per hour. Let's refer to the amount of time as T sub r for the amount of time it took to run 4 miles. So for running, we have rate times time equals distance. For biking, the rate is X plus 4 miles per hour. And let's use T sub B for the amount of time it took to bike a distance of 12 miles. Okay, then what does the problem tell us about the relationship between T sub r and T sub B? That is the amount of time running and the amount of time biking. What does the problem tell us? Well, in the first part of the first sentence, in 1.5 hours, so a total of 1.5 hours, Staley rode a bike 12 miles and then ran 4 miles. So we can write a third equation. We can write the amount of time it took to run 4 miles plus the amount of time it took to bike 12 miles is 1.5 hours. I'll just write it as 3/2 instead of 1.5. Okay, so the next thing, remember, since we want to solve for x, we need an equation whose only variable is x. So we're going to use these 3 equations to help us. We'll solve this equation, x times T sub r equals 4, solve that for T sub r. So time is equal to distance divided by rate. So the amount of time it took to run 4 miles is equal to 4 divided by x, distance divided by rate. The amount of time it took to bike 12 miles is 12 divided by x plus 4. Time is equal to distance divided by rate. But we know that the sum of the times is 3/2. So that means we can write 4 over x plus 12 over x plus 4 equals 3/2. So now we have an equation whose only variable is x. Okay, it's an equation with rational expressions. So generally, we find the least common denominator. So the least common denominator is 2 times x times the binomial x plus 4. And then we multiply every term on both sides of the equation by 2x times x plus 4. When we multiply 4 over x times 2x plus 4, the x's will cancel. And so I'll write it as 2 times x plus 4 times 4. We still have a factor of 4. Then when we multiply 12 over x plus 4 times 2x times x plus 4, this time the x plus 4 factors cancel. So we'll have 2x times 12. And then on the right-hand side, multiply 3/2 times 2x times x plus 4. This time the 2's will cancel. So we'll get x times x plus 4 times 3. Okay, what we have is a quadratic equation. So we'll multiply everything out and set one side equal to 0, and then solve the quadratic equation. So this first term, notice if we multiply 4 times 2, we get 8. And then 8 times x plus 4 is 8x plus 32. And then 2x times 12 is plus 24x. On the right-hand side, 3 times x plus 4, we'll get 3 times x squared, 3x squared, and then plus 4 times x times 3 is plus 12x. Okay, so on the left-hand side, we have 8x plus 24x for a total of 32x. So we're going to subtract 32x from both sides and also subtract 32 from both sides. And so we'll get this equation, 0 equals 3x squared minus 20x minus 32. So let's set this up and using the quadratic formula. So we'll take it a certain distance. So let's see, over here I'll write x equals the negative of negative 20 plus and minus the square root of the number negative 20 squared minus 4 times 3 times negative 32, all divided by 2 times 3. So the negative of negative 20 is 20, and then plus or minus the square root of a number inside the square root. The number negative 20 squared is 400. And we're subtracting a negative again, so that's going to be plus 12 times 32. So that's 384. 384. Let's see. Yeah, I think that's right. And then divided by 6. So I'll just take it one step further. Notice this number, the square root of 400 plus 384, is bigger than 20. So we don't want the negative solution. So we just want the solution we get by adding. So 20 plus the square root of 784 divided by 6. So you can use a calculator for that. The directions don't say anything about rounding, but okay, there's a little over 5 minutes left. I do have other problems. So we can at least get started on one. Is there a particular type of word problem that you want to look at? I have several types. This first one is uniform motion involving rate times time equals distance. The second one is pretty straightforward. It's just a certain number of children and a certain number of adults buying tickets at different rates. The first one? Okay. So the request is for the first one on uniform motion. This one says Wooster rode his bicycle the same distance in 2 hours as Finknottle rode his bicycle in 3 hours. Wooster's speed was 4 miles per hour more than Finknottle's speed. Find Wooster's speed. Okay, so for Wooster, we're supposed to find Wooster's speed or Wooster's rate. So since miles and hours are mentioned, let's say that Wooster's rate or speed is X miles per hour. Okay, and then make sure we're careful when we write down what Finknottle's rate is. So Wooster's speed was 4 miles per hour more than Finknottle's speed. So since I picked X for Wooster's rate, Finknottle's rate is X minus 4 miles per hour. Okay, so for Wooster, Wooster rode his bicycle for 2 hours. So rate times time, we're not told what that distance is, so I'll just say capital D. And then for Finknottle, his rate, X minus 4 miles per hour, he rode his bike for 3 hours. But we are told that they both rode the same distance. So Finknottle also rode a distance of D. Right? So since the distances are the same, we can write down the equation whose only variable is X as 2X equals X minus 4 times 3. So this is a pretty simple equation to solve. 2X equals 3X minus 12. Subtract 2X from both sides and add 12 to both sides. We get 12 equals X. We can check to make sure that makes sense. If Wooster's speed is 12 miles per hour, his distance is 12 times 2 miles, or 24 miles. And then Finknottle's speed is 12 minus 4, or 8. 8 times 3 is also 24. So everything checks out. Well, we have less than a minute, so it's probably not a good idea to start another problem at this point. So I'll be sending an email pretty soon with the Zoom link for the final exam on Monday, May 3rd. So go ahead and sign in for attendance. Was there
something confusing about that? No, it makes sense. You're in that place.
Yes, I am. I got into a car wreck yesterday. Got nasty with flash. I got into a car wreck yesterday.
Oh,
Got
you did?
nasty with flash.
Ouch.
Yeah. Turns out you can also get a concussion without hitting your head. I didn't know that. Thank you.